Hi there, Mrs. Hassler here. I'm going to go over the 7.3 notes with you. We are looking at parabolas. We are going to discuss the domain and range for parabolas, as well as the intervals of increase and decrease. Remember that a parabola is the graph of a quadratic function. And so when we're dealing with um, parabolas, what we're really talking about are functions in the form y equals ax squared plus bx plus c. And that type of function is what produces this U-shaped graph. So recall that domain is the set of all x values anytime we're talking about the domain, we're talking about input or x values, anything that is running along this x-axis here on our graph. And so the domain for this f of x function, this parabola, is the set of all real numbers. And what that means is that I can take any number and put it in place of x, and I will always get a y value out for it. So any number that you can think of, you can always substitute it into that quadratic function, and you will always get an output that matches that x. Remember that range is the set of all y values. Or all of the outputs, as I had just mentioned. Numbers that go into the function are inputs or domains. So the answer, the output, are the y values. And so, when we're looking at y values, we're looking at things that line up here with this y-axis here. And what's interesting about this is that not every y value gets used. In fact, you'll notice that below this y value right here, there are no other y values that get used below that y value, and that y value happens to be -9. In fact, in this particular case, every y value -9 or higher ends up getting used, but any y value below -9 does not get used. So that means that the range is a little trickier than the domain, okay? All right, so how to find the range of a parabola? Well, if I have a minimum, which means if my parabola opens up, then that means that all my y values are greater than or equal to some number, okay? And if I have a maximum, which means that I open down, then all of my y values are going to be smaller than or equal to some number. And that some number that goes into this right here, that some number that goes right here is the y of the vertex. Okay, so we use the y of the vertex. Again, notice when I'm over here, the y of my vertex is -9. And because this graph has a minimum, it opens up. That means that all of my y values are greater than or equal to -9. And so I'm using the y of the vertex to indicate what the range values are. Okay, so now we're going to talk about the increasing and decreasing of this function. Let's see if I can erase this here. There we go. Okay, so it says to highlight or color the section of the graph that is decreasing. All right, and so I'm going to do that. Decreasing means moving downwards, and so decreasing means I'm moving in a downwards direction. And so I'm just going to scribble in the section here that is decreasing, 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 decreasing. Okay, and then it stops. In fact, this is this right here. Look at that vertex. That vertex, by the way, which is 2, -9, is the point in which I stop decreasing. All right, so it says describe where f of x is decreasing. Well, f of x is decreasing for all x values to the left of 2. So all x to the left of 2. And so when we say on what interval, what we're doing is we're going to list. I take that back. I don't want to say list. we are going to give our answer in terms of x values, okay? Answer using x. So when we talk about this interval, we're going to be using x's to answer. All the x values to the left of 2 are where my y values are decreasing. So my y values are decreasing, my function is decreasing for all of the x values that are to the left of 2. So all the x values to the left of 2 are all x values that are less than or equal to 2. Okay, let's try another one. Let's do this for increasing. So highlight or color the section of the graph that is increasing. Well, starting here at an x value of 2, my graph is moving in an upwards direction. It is increasing. So increasing means I'm moving upwards. Describe where f of x is increasing. Well, f of x is increasing for all x to the right of 2. Okay, so again, we answer using x. Okay, so again, my function, my y values are getting larger and larger and larger. They're increasing, and that's happening for all x values that are bigger than 2 or to the right of 2. So x is greater than or equal to 2. All right, and again, we use this vertex to help us answer our questions. All right. Okay, so let's come down here and give this a try. It says state the domain and range of the graph or table, then state the intervals of increase and decrease for each. Okay, so let's go through this. And domain, well, domain for a parabola is always all real numbers, and we can use that symbol, that double, that stem with the, or that R with the double stem, all real numbers. The range, however, depends upon the vertex. So I'm just going to identify this vertex as -1, 4. This is a maximum, which means all my y values are smaller than or equal to the y coordinate of that vertex. Increasing, so again, I'm going to use my highlighter. So increasing, it looks like this section is actually increasing. I read the graph from left to right. This section is moving upwards. And again, that's going to stop when the x value is -1. So I'm increasing for all values to the left of -1. So x is less than or equal to -1. For all the x values that are to the left of -1 or less than or equal to -1, my graph is increasing. And I'm going to say that I'm decreasing starting when x is -1. And so for all the x values to the right of -1, or for all the x values that are greater than or equal to -1, my graph is moving downwards. Okay, and that's how we answer that. Let's take a look at this table. This table is interesting. We worked with tables in the previous lesson. Again, as a reminder, the easy answer for the domain of a quadratic function is all real numbers. All right, and so we talked in the previous lesson about identifying what the vertex would be, and it looks to me like we have a vertex right here at 0, -12. I know that's the vertex because, so I'm going to just write that as an ordered pair, 0, -12. I know that's the vertex because I notice that on either side, I get these repeating y values. And so because I have these repeating y values, where the -12 does not repeat, that means that the vertex is at 0, -12. That's the only coordinate that has the y value -12. Everything else repeats on either side of that. And the other thing that I notice is that these y values are getting bigger on either side. In other words, if I were to graph 0, -12, my y values on either side are getting larger, which means that I have a minimum. So a little bit of thinking to do here. That means that my y values are all going to be bigger than or equal to -12, the y coordinate of that vertex. So some thinking to do. Notice that we're sketching some graphs like we did yesterday in the previous lesson. Okay. All right, so let's use the same idea to kind of help us think through where we would maybe be increasing or decreasing. All right. So let's see. If I have this sketch of my graph, it looks like I'm starting off by decreasing. All right, so I'm going to put that down here. And it looks like I'm decreasing to the left of my vertex. I use the x value to answer this question. So for all x values less than or equal to 0, I'm decreasing because I'm to the left. That's the decreasing section, is to the left of my vertex. So x is less than or equal to 0. And let's see, to the right of my vertex, I'm increasing. So that's this right here. To the right of my vertex, I'm increasing. So for all x values greater than or equal to 0, I am increasing. All right. And so now you're going to get the chance to practice this doing an activity. And if you have any further questions, please ask your teacher.